Yeah, with that, one should.
Managing cloud-hosted enterprise metadata portals.
Speakers.
Live streaming is on.
Yeah. Okay. So the first speaker of the day is Brian Johnston from the Ordnance Survey, and Brian is a technical consultant for the Ordnance Survey, and he'll speak on accessing OpenStreetMap downloads with API with R.
Yeah, that's okay. I'll just there we go. Cool. So yeah, I'm going to be talking about the OS Downloads API and how you access that to download OS Open Data products using R. I also give this talk kind of a bit of a subtitle of probably the least technical R talk that you're ever going to hear, but also I think that that's a good thing because it just shows how accessible some of this stuff is in kind of getting it into your workflows. So what is the Downloads API? So Downloads API is an API that Ordnance Survey has created to allow people to come into our databases and pull the products that they need as part of their workflow. They can use that URL to download the specific product that they've selected and bring it in. And essentially, the main use case for this is just to simplify workflows. If you can use the API in that way, you can automate that download process and kind of simplify how you're undertaking your tasks. So as I said, the range of different benefits for this. As I said, you can automate, so you don't have to go on every month, find your data and bring it in individually. You can also schedule it. Number of customers we have who come to us and say that, oh, we missed that download because in our kind of backlog of records, how do we get a previous epoch of the data? So if you've got it scheduled, you can bring the data in when you need it. You can also ensure that your local data holdings have the most up-to-date version of the data held locally. And also it reduces and limits opportunities for kind of human error in your process. Once you've got it automated, you can bring it in without somebody misclicking a button at that inconvenient time during a download. It's time saving. You can set it up to run when everyone's asleep, so that you're not taking time out of your regular operating system. And also you can fully integrate it with your onward steps. So downloading it can be automated, and then loading it into your own locally held databases can kind of be made part of the same workflow. So this is the Downloads API in terms of accessing open data and the kind of the operations that exist there. And as I said, it's not a very technical thing. It is a very simple and straightforward process. We have a series of operations just to look at the products that are available, and then also to extend that to get in and look at to obtain your download links for those products. So in this little use case, what I'm going to do is I'm going to download OS built up areas. So this is our newest open data product. It was released just before Christmas last year, and it's a data set that essentially shows the boundaries of a settlement built up based upon the built upness of an area. So it's different from National Records of Scotland's settlement boundaries in that it's not based on population, it's built up based on the actual structures that are present. In addition, it has two components that are added to it. Built-up extents, which are a bit tricky sometimes to explain, but they're the built-up areas within a built-up area, because we've also got the non-built-up extents, which would represent green spaces or empty areas within those built-up areas. An excellent example is just behind us in Kelvin Grove Park, would be a non-built-up area extent within a built-up area. So that's how this data is structured. It's also based on grids, a gridded structure, kind of making it a lot more friendly for kind of data analytics use. So the first step to using the Downloads API to bring that data and download it to your local holdings is you've got to go get an API key. All of our API keys can be obtained from the OS Data Hub, and you can register as an open data user there. Once you're there, it's actually exceptionally straightforward, but there's a tab that says API Dashboard. You go in and you click Add API, and once you've done that, you can generate a Downloads API instance with the key present and visible for you. Obviously, we suggest you don't share your Downloads API key, otherwise everybody else is going to be feeding on your one key. But it's if you ever have an issue with your API key being compromised, you can regenerate that in a really straightforward way using the system. So as I said, this is probably where this starts to get the little teeny bit of technical, which is actually how we're going to do this in R. The reason I've chosen to do this in R in this instance is because we did get a customer request of how do we do this, particularly from the healthcare sector, where folks in that setting much more familiar with R than any other software package. So we had to try and tackle this problem. Firstly, we call a couple of libraries in there to let us look at the data that we're pulling in from the API, and then we pass the URL, kind of the get command for the URL built from our API key. From that, then we can do the products call to look at all the products that are available as open data. And what we get then is a return of the list of products, getting all 18. There is a hide that. There are 18. Vector Map District is present as well. So we get the 18 open data products that are released from Ordnance Survey there. We can then use that view to obtain the ID, which is what we're going to use to call the open data product eventually. So yeah, as highlighted, those are the IDs, and there is the built-up areas. So to call the built-up areas, I need to know built-up areas, capitalized letters on the first of each of the words, all one word. From there, I can essentially build my URL to link to that product download using that built update. I can then take some time and look at the different names that are present within that URL as kind of extensions from it, and know that the two that I'm interested in is the URL, as that's the downloads URL, and the file name to just simplify the process of downloading to my work directory. Just a quick loop to summon the download. and I can pull both the files that I need down to my local drive. As I said, that's it. That's anything technical done. I said it is very straightforward to pull this data down to your local settings. From there, I can just drag and drop those files straight into Q, or if I wanted to, I could use R to unzip those files and start doing my analysis in R, or I can automate the process to send it to my Postgres database. Whatever my choices are, I can do it from that point, but once I've got the data locally stored. So we have built a whole range of different instruction sets. So this was the R one, but we've built it for everything from looking from FME and Power Automate to Bash scripts and Python. And usually we can figure out how to make it work. So if you've got any weird or unusual softwares, feel free to reach out to us and we'll try and offer advice where we can. And these here are the links to those technical specifications for how to access this going forward. And that's kind of my run through accessing an R. That's me.
We will do a round of questions after the second talk. Depending on how much time we have, we can ask a couple of questions. Yes, is that all right? Yeah. All right. The next speaker is Amy Taylor from Corder Forestry. She will be talking on tree rings, visualizing forest plan data with R.
Great, thank you. Okay. Thank you. So tree rings was the name that I came up with for a visualization that I created as part of a University of Edinburgh data visualization course I did back in 2021. And my motivations for doing that course were that it was an opportunity to learn more about the data visualization process and the design process. And also it was a deadline driven opportunity to use R because I'd been wanting to look at R for a long time and had never had the kind of the correct motivation. So having a deadline focuses the mind on that front. So I work for a forestry consultancy and it was a bring your own data course. So I decided to use long-term forest plan data. This is comprised of 3 main data sets. So the first one would be the current species data. So that's what's actually growing on the ground at the start of the plan. And we would usually show that in terms of a map legendized by species. So in this map, you can see the green areas are Scots pine, the blue are Sitka spruce, the red hatched areas are unplanted, so they've been felled. So, and that's all stored in our forestry database. Then the long-term forest plan layers would be the felling phases. So we use the standard Forestry and Land Scotland shading for the felling phases. So the red is the first phase. Each phase is 5 years, and a long-term forest plan looks at a 20-year span. So the first phase is the red areas. They're all going to be felled in the next 1 to 5 years. The orange areas in 5 to 10 years. Yellow phase 3 and green's phase 4. Anything that's blue is either too young to be considered within the scope of this forest plan, or the light blue's long-term retention. So they're going to be kept for management reasons and not felled. So that's the felling phases. And then the final layer is the restocking species. And that's once an area has been felled and then it will need to be replanted. I should say this is commercial timber we're looking at here. So you have to restock with trees after you've felled it. And then if you look at the current species and the restock species, that would give you an overview of how the forest is going to change and evolve over the course of the forest plan. So those were the 3 data sets I wanted to look at. And my idea was that I wanted to produce a single graphic, a single visualization that would encompass the character of the forest plan and of the forest. So at the moment, we visualize these data and present these data as part of the forest plan as a suite of maps and charts and tables. There's kind of like a dashboard of different graphics that we produce with this data. And I wanted to really produce an image that would encapsulate all of that in an interactive way. So in addition to showing in a nice way, hopefully, how the data was, a user would also be able to quantitatively assess things, so it wouldn't kind of just be a pretty picture. I was really inspired by circular images. The image on the left there is a genome browser graphic. I have absolutely no idea what the data is that is showing, but I just think it looks like it's showing a lot of information. There's a lot of data points, a lot of complex information on there, and it's in a very attractive way. So I was really taken by the idea of a circular graphic. And then we had to do a design tutorial where we broke out the color in pencil. So this was my initial sketch of what I wanted to show, which was kind of like a exploded pie chart pizza thing. So in the center there, I would have the current species, and then a ring that would then show of that species area, how much of that's going to be felled in each phase, and then what's the restocking species going to be. So that was my concept diagram. So in terms of the data processing, initially the preliminary data cleaning and analysis I did in QGIS and Excel, because although I wanted to learn how to use R, I should say this is probably actually the least technical R talk you will hear, because there's no code here. I only had 12 weeks, so there was a lot of the data processing and tidying up that I just had to do in QGIS and Excel. But then the learning curve for me really was the actual creation of the visualization and the exploratory data analysis, and just seeing how the data looked in different ways when you ran it through different functions. So this was a circular process. The results of me intersecting my data set and cleaning it up were basically one big polygon layer, and the attributes of that I wanted to look at were the current species, the felling phase, the restocking species, and then the area for each polygon. And I fed that into R. It was a CSV file, and just ran it through lots of different scripts and functions to create all these different graphics, and hit upon sunbursts. So a sunburst is a hierarchical visualization. So if you've got a data set with different hierarchical levels, then you would have spokes that come out of the circle. But my data set, every polygon has got the same 3 hierarchical levels. So it comes out as a set of concentric rings. And in this, I've got a central ring, which is the current species. I've got a middle ring, which is the felling phase, and then I've got an external ring, which is the restocking species. So that ticked a lot of the boxes in terms of how I wanted the data to look. And then when you click on things, if you click on a wedge, it highlights that wedge, and then this little tab pops up to show you the statistic, the percentage area for what you've clicked on. So there's a level of interaction with that. And I did some user feedback with people on my course, but also with people at work. And the main thing that came back from that was that in order for this graphic to be intuitive, and for somebody who's in forestry to be able to just look at it and think, oh, I can see what's happening there, was I would need to use the legends from the maps, so the color coding that everyone's familiar with, and put that into the graphic. So that was my first big Stack Exchange win, was that somebody had asked that question and someone else had answered it. So I was able to plug the code in so I could define what the colors were for the species and for the felling phases. So that generated this version of it, which again, it was quite nice. You could still get some level of interaction and see things. And this meant it was from somebody in forestry, they could instantly look at that and say, well, this woodland is almost 50% Scots pine with a little bit of Sitka spruce. So you're able to glance at that and take things away from that without necessarily having to click on things. The feedback on that was that it was great. People liked it, but the outer ring, the restocking species ring, because it's increasingly segmented as you go out from the center, it's quite hard to see the detail of that. So here I've clicked on Scots pine, felling phase 1, and you can see the percentage of Sitka spruce which is going to be stocked, and there's tiny, so you can't really see the detail of the outer ring. So they got work. We're saying, well, could we maybe show that information as a separate side chart, or can we zoom in to show more detail? So the Stack Exchange big win number 2 was that yes, you can do a zoomable sunburst, and it's probably better if I just actually go to that. So that's the final image in this process was a Plotly. It was in the Plotly library in our studio, and it's a sunburst function. And the main issue I had getting it into that format was, well, what does the data need to look like to go in to feed into this function? And that was where the Stack Exchange win was. Somebody had posted that question and answered it. So I was able to incorporate that code with the color schemes to produce this final design. So if I click on this, hopefully it'll open the web page. So this was the final graphic I had, and if you hover over these things, it shows you what the percentages are. So you can see you've got 43% of the forest is Scots pine, and then if you click on that, it recenters it, and then you can see, well, of that Scots pine, 1%, 3% is going to be in phase 1, and then the restocking species for that is going to be mainly Scots pine with a bit of Sitka, some mixed conifer, and smoking ground and native broadleaf. So you're able to, by clicking and hovering over things, you're able to actually get quite a nice amount of detail from this. So back to the PowerPoint. So that was great. Yeah, but the feedback I had from that was that was great, but what the foresters actually wanted to see was the before and after for the restocking species. So that involved jiggling the hierarchy around a bit so that felling phase was at the center of the image, and then the current species was the middle ring, and then the restocking species was the outer ring. And there was also a bit of contrast between what my classmates thought with regards to the colour schemes and what the forest managers thought. The people in my course were saying you should use more modern colours and make it more muted. But then if I did that, the people at work were like, we want to see the colours that we're used to so that we can look at this and know immediately what's happening. So everyone was used to Scots pine is green, Sitka spruce is dark blue, European larch is orange, and those colours tied in. So the concession I made was that I made the felling phases a bit more pastel-y. That was the kind of compromise. But then, so this final image, so you can see phase 1 here, we've got the composition of the areas that will be felled in phase 1. And then if I click on the larch, it's a very good example, because this is data from the last forest plan we did. This one's coming up for renewal. So this was from 10 years ago. There wouldn't be any larch in that wedge anymore because of Dothostroma. So you can interrogate this and look at different things. I mean, somebody could click on that and see that larch and think, oh, well, I'm going to look into that and figure out where that is so that we can remove that. And yeah, the feedback we've had from this has been really nice. Everyone says it's interesting. I think in terms of my future goals, I would think that I would want to do more of this process within R. So I did some of the initial processing in QGIS, and ideally I was really hoping to have a process that I could press a button, select the 3 layers that I needed to look at, and then run that to generate this graphic. Also dealing with the species mixes. In that graphic there was quite a big wedge of light green, which is mixed conifer, which was my compromise in terms of where we've got areas that are intimate mixes of lots of different species. I'd need to split those out on the percentages and use that in some sort of script that in somehow. And then also it would be great if I could make this part of a dashboard so that when somebody was looking to make a forest plan, they clicked on a button and then this image came up as maybe the steering wheel for all the other charts and graphs that we usually produce. And if it linked into the geometry, so you could click on a bit of a wedge, a bit of the sunburst, and then that flashed up on the map, that would be splendid. But those are all things that I didn't have the time to do with this. And I think I probably ran through that quite quickly, but yeah, that's me. Thank you.
I think we have some time for 2-3 questions, if there are any, for both of the speakers.
Just about famous API.
Mhm.
Well, premium data sets, how do they just what credentials and
So the premium data sets pretty much the exact same color instead of the end protocol product for open data set or simple data packages for the premium data sets. So you set up your data package for premium and then go with
what's the old data set?
Open or
So it's data platform and user API, and then would it be maybe a 2 months old, or would it go like last month?
So if you're pulling from your open products, it would be the most up-to-date version of the data. You don't really have to get historical data sets. Yeah.
Yeah, for the open data, yeah, brand to the right, it's always the current data set. For some of the premium data packages, obviously, if you set up an order on the OS Data Hub, you can keep all of your older orders there, and then the new full refresh updates get in. So it depends when you set up your orders.
What's the source of data?
So the data I was showing there, the vivid assessment boundaries, comes from observed data, which is captured from buried inventory or observed on ground. So it's essentially it's all survey data to summarize those boundaries.
All right. Yeah. Yeah, go ahead. No worries.
so sorry, I think
So like what is the feedback in terms of green packages and
I mean, I guess for this particular visualization, it would be forest plan. So we have this statutory submit a forest plan for anywhere that's going to be felling and stuff. So this would be complement to the forest. So the forest is using that planning operational side of things, and also then the yeah, happy with the data sets, but this was done, although I use my reports data, this was actually done in my free time, so we're not actually implementing that in our workflow, but it would be nice to that was something that yes, well, back in 2021, I think it was that data visualization for professional environment. For the upskill courses they did after COVID. So I'm not sure if they're still running courses, but I think I signed up for it in January and then started in the run. But I think that's been used as well.
Are there any other questions? Yep. Sure. Can you put that on?
Our forestry database is based on aerial surveys that are then ground truthed by the foresters. So we would do an initial kind of stratification based on what you can see in the photographs. And then,
helicopter taking a photo.
yeah, well, there's people based in Inverness who do aerial photography from a fixed wing plane. So kind of standard aerial photography. A lot of the data sets that we are working with have been established now for over 20 years. So someone else has done the digitizing and done all that. And then my job is to keep that up to date. And so when things are felled or when things are replanted, then somebody goes out, and we tend to use phones now for GPS because that level of accuracy we don't need like centimeter precision accuracy for where the trees stop and start. So someone will go out and they'll measure the boundaries when something's been replanted, and then I'll update the database based on that GPS data. But initially, most of them are based on photography surveys.
So you're not giving trees what 3 words locations for.
No, we do use what 3 words for the harvesting sites. For that's one of the kind of operational things for the contractors on site. They obviously have to be if something happens, give the emergency services a very quick reference for where they are. So, I mean, and joking aside, for in your middle of a forest, what 3 words is a pretty good way of saying that. But and I have been asked to convert what 3 words points into maps for other things, not for the forestry, but for some other work to do. But yeah.
I guess the sort of follow-up to that was it's quite topical about sort of adding in tree health, and in terms of when people are assessing forests from the sky and from the ground, sort of Heather plans to sort of enhance that potentially to include.
Yeah, so that's a big thing that we're interested in terms of, at the moment, to assess tree health, someone has to go out and do like a physical walk around, and that's how we would, before you harvest anything, you have to obviously have a measure of what the value of that crop's going to be. The other trees, but also with all the different trees. But I think we are not doing much of that at the moment, but in terms of using either drone imagery or satellite imagery to automatically detect those things, I know there's a lot of work going on.
I can really see how like a tool like that could be used as a great visualization aspect for.
That was the thing when I did this. I showed the guys at work. They were just like, "Oh, there's so many different. Like, we could use it for this or that." There's so many different applications to that.
All right, I think we should probably continue this after during the coffee break. I would like to invite Anna Basiri for just a few minutes to talk on a geospatial data science group at the University of Glasgow before we go into coffee break.
I know that I'm standing between the coffee and you, so I will be very, very brief. I'm supposed to just introduce the team because that's a part of the sponsor. So we started about 3 years ago at the University of Glasgow, and now we have grown quite rapidly over the last 3 years. There are still some posts, so please pass them to others. And we have a lot of plan to include more collaboration with industry, with government, with public, as well as other universities. So come to us, talk to us. Most of our research are related to geospatial data in the form that try to understand the fast changing environment around us. So we use a lot of what we call new forms of data, like mobile phone data and social media data and so on. But we also have a lot of activity related to crowdsourced platform like GPS crowdsourcing. So we can actually map, contribute to the 3D mappings and other activities that happen with position and the navigation in the cities and society. So I don't want to take your time. I just wanted to say thank you very much, and you're very, very welcome to come to anyone in the team. Well, 2 of our fantastic team are here chairing this session. And I must say that at the beginning, you said I helped. I did absolutely nothing. So they're all to blame, anything if it goes wrong. So thank you very much. Enjoy your coffee and come and talk to us if you have any possible collaboration idea with us. Thank you.
Yes, so now we have a coffee break, and I think we should come back at 11:20, right? Yep, for the next session. And if you're wanting to go to the workshop, the workshop will be in the room here on the right. So that will also start at 11:20. Thanks. Anything else? Oh. Did I miss something?
I start. Okay, so
Live
I'm. Oh,
streaming
there we
is
go.
on.
Fantastic. We all missed my mumbling at the beginning. Brill. So I'm Mike Spencer, and my colleague Rosie is sat in the audience there. Do feel free to come and have a chat with us sort of after the talk about various things. I'm here to talk about the index of multiple deprivation in its various forms. How's this work? Oh, it works on a wheel scroll. There we go. So first off, what is the IMD? I've put a little asterisk there because it's, I suppose, lots of different things. But the IMD is index of multiple deprivation. So it takes a whole range of different indicators and combines them together for an understanding of what an area's deprivation might be. And it's different for England, Scotland, and Wales because it's a ranked index. You can't, across actually different criteria for each different nation, you can't join them together. You might see them joined together in some places online. They're wrong. That's fine. But they cover things across health and income and sort of access to geographic services or geographic access to services, education, various other things. It's used in the public sector for, I suppose, for policy kind of decisions, but it's also used to drive intervention. So at a local authority level, where should we, sort of target services, or what kind of changes do we want to make? I suppose, like, because it's a ranked index, there are some strange things there that you can, like, I suppose here we are in a university.
Streaming is on.
of the metrics that go to make up that income category are how many people in an area are on different types of benefits. And that doesn't mean to say that's not an entirely valid metric, but I think given what we've talked about on cost of living crisis and things like that, what some of the challenges we are seeing are not related to potentially long-term financial vulnerability. They are sort of new and emerging situations of financial vulnerability where potentially sudden and dramatic changes in energy bills have left someone in a, or households in a financial problems. I'm seeing Ross there with his head in his hands, and I'm wondering if I've touched a nerve, but I don't know. He can come and kick me afterwards. And so, so that kind of situation means that maybe we shouldn't just be focusing on benefits. So I guess what I want to talk about, and I'm kind of getting there just about, is how do we supplement or enhance the index of multiple deprivation? And I suppose what I would think about as desires for this would be, it should be near real time. Like it should allow, say, a local authority or sort of policy or intervention kinds of decisions based on data that is as close to real time as possible. It should link into administrative spatial resolution, so data zones in Scotland or LSOA type things in England and Wales, and it should help us see these evolving situations. So things like the cost of living crisis, where you would take a potentially a traditionally wealthy neighbourhood who have bought houses with period features and discovered that their energy bills have suddenly become really brutally high. And that's not going to be something that would capture in, say, counts of benefits, as it's not a sort of an area of traditional financial vulnerability. So how can we, and this is we as a Smart Data Foundry, help in this situation? So I think we can only offer part of the solution. So we work with people like NatWest Group and EPCC, which is the Edinburgh Parallel Computing Centre, and we help, or we host, curate financial data from people like NatWest in order for people to access it for sort of research or for public sector type insight things. We operate on a 5 SAFEs principles, and we use the same infrastructure that things like the NHS use for patient records, and the same controls and governance structures that are around that in terms of who can access it and what for, and all those other things. So that national safe haven infrastructure also comes along with information governance. And I'm saying these things because often when we as an organization give these talks, it's frequent for someone to come at the end and say, I'm an NatWest customer, I didn't know my data was doing this. So there are all sorts of controls and anonymizations in place that makes it extremely difficult, if not impossible, for us to actually identify people. So it's about how do we do this kind of work safely. So what does this mean in practice? Toy data, definitely not real data. So this is the kind of stuff we get from NatWest. We get anonymized ID, we get sex information, it's just male and female. We get data aggregated on a weekly basis, and then we get a breakdown of sort of income categories, we get a breakdown of expenditure categories. These are the ones that the bank has to report to the Financial Conduct Authority, and then we get some things around cash balance at the kinds of beginnings and ends of periods and that sort of thing. We are working with NatWest to get sort of different levels of categorization, but this is currently effectively where we stand. And so what we then do is we use this safe haven infrastructure to transform this data about individuals to statistics about an area or a group. So taking that personally identifiable or potentially personally identifiable information and saying, well, in this area, overdraft use might be 20%, or in this area, or in this group of pensioners, we're seeing the spend on energy bills at this kind of level. I keep expecting the arrow keys to move me on, but we'll get there. So some of the sample metrics, have we lost the screen? Oh, no, we're back. Fantastic. So some of the sample metrics that we've been looking at are things around benefits dependence. So this relates quite closely to the things we've seen on the SIMD. Some things on overdraft use, I mean, I don't know. I have opinions on overdraft use, but it's actually does seem to work quite well. And also some things on income. So like rather than purely say relating things to deprivation or benefits, is going, well, actually, what is the average income within this area? And we can use those kinds of things for potentially around workforce planning. So saying if you are a large employer and you want to recruit people within a given salary band, where do you target say, letter drops or mailing campaigns or that sort of thing in order to have those recruitment policies. So that could be important, say, for the care sector, or maybe things like airports or organizations like that. So we've got some caveats. What you're going to see is entirely work in progress. Think of this as market testing or sneak peek. It depends. I don't know. I don't mind. There are some smallish sample sizes, which possibly Anna might want to ask me about later on. I've got some other information on sort of the missingness around this data. And what I've done here is some really quite crude spatial joins between postcode district and between data zone. Which we are working with NatWest to improve, but for the time being and for this, there are some fairly crude spatial joins and some aggregations going on behind that. So don't take any of this as sort of absolute values. So first plot. The index of multiple, or the SIMD compared to benefits dependent by postcode district. So each one of the dots is a postcode district in Scotland. There's about 400 of them. And this is for, where are we now? August. I think this is for the last week in July. So it is the percentage of people, or our data are the percentage of people within a postcode district who have who rely on benefits for 60% or more of their income. And then on the x-axis, we've got the index of multiple deprivation income group. So we can see, and the line is a one-to-one relationship. There's actually surprisingly quite a good relationship there, considering that, like I say, there are some caveats. We've obviously got some missing data down here where we've got a whole lot of zeros going on. This is probably due to some relatively small sample sizes. I say relatively small. We've got 1.2 million customers records for GB, which translates to a bit over 100,000 for Scotland. But when we start breaking them down to sort of postcode district or sort of age band or income band, it does make for some quite small data sizes. Clearly not a map, and we're here for spatial stuff, so I should probably talk about that a bit. We've had 2 talks on R already. For those of you who are eagle-eyed enough, I'm using R for all of my plotting, and I will have a quick couple of lines of code at the end of the talk to show how I made some of these figures. But what we've got here is the deviation from the index of multiple deprivation income category to our benefits dependence. So where it is sort of that below 0, that is our value is slightly less than the SIMD one, and where it is more than ours is sort of a higher value. So we're seeing, I guess, like lots of increases, but then these metrics aren't quite the same. That the index of multiple deprivation is how many people have any kind of benefit that's not, say, child benefit or winter fuel, and ours is where is that high dependence for income on benefits. The grey areas are effectively missing data, i.e., I suppose if you're a banking competitor, you might be able to infer some market share there about NatWest customers. However, you could probably just do that from the location of branches. So the next one, overdraft use. So I mentioned earlier, I have some slight caveats around this. I used to have an overdraft when I was an undergraduate, and after a few years, the bank weaned me off it by gradually reducing my overdraft value and then telling me I couldn't have it unless I paid for it, which is entirely reasonable, I suppose. But my thought about this is that actually it's not, most banks, I suspect, are like this. And when you try and go overdrawn, your charges will be declined. So these are agreed overdrafts, I would presume, and an agreed overdraft is unlikely to be given if you are or if you have a history of financial vulnerability. So likely this is not that traditional group of benefits claimants. This is people who have potentially been wealthy enough that the bank's happy to lend them money on a, some kind of fun interest overdraft rate, because they're expecting to get it back because they know that they're getting that income. So these are, I guess, potentially some quite different indicators here. And again, in map form, so we're showing basically much higher overdraft use than for most of these areas than we would see in sort of benefits. Again, this is super early work. It's interesting that sort of the upper D around about Braemar is really high. I don't know. Could that be something to do with it being a long way off the gas grid and it being expensive to heat properties up there? It's often sort of Braemar is one of the coldest places in Scotland. It's not unusual for it to hit -20. A lot of these are quite rural areas, so it's there's some potentially interesting things around sort of transport poverty or fuel poverty within that. And the last one of these is comparing to income. Now, I don't have a map for this one for hopefully some relatively obvious reasons, that trying to compare financial values against percentages is not sensible in terms of subtracting one from the other. But what we've got here again is that each dot here is a postcode district, and we can see that for the really high levels of SIMD income deprivation, that we're also getting low income levels. But we've also got over on the left side of the graph, we've got some of the lowest income groups that don't have a high level of SIMD income deprivation. And I don't know, there's possibly lots of things that are going on there. Maybe it's just a low wage area. Maybe it's not sort of high cost areas. Maybe it's like an older population where the pensions are lower, but they don't have particularly high outgoings. I suppose there's all sorts of things going on in that space. How are we doing for time? I'm not going to talk about averages, but clearly these are a long way above where we might expect income figures to be, and that's to do with sort of means and high earners pulling up those means rather than necessarily relating to the general or the most general population. So the other cool thing we can do with this data is that we have this on a weekly basis. So rather than say like in map form where we might just show things statically, we can show this as a time series. And I've talked for a long time, so I thought I'd do this like a quiz. We've got here, every one of these lines is a different postcode district in Scotland. So where it is darker, there are more and more of them overlapping. So we are here in the G12 postcode. Where do we think the G12 postcode sits on this benefits dependence in Scotland? So I guess hands up for really low. Hands up for somewhere in the middle. Hands up for somewhere high. Okay, let's have a look. So yeah, it's really low. We kind of, I suppose we might expect that. It's one would expect like a relatively nice area of Glasgow. It's not Edinburgh. And so that's kind of reflected in this sort of benefits dependence. The same thing again for overdraft use. Where do we think that, I'm kind of ignoring all the stuff above 25% because that's mainly just outliers and small sample sizes. So within that kind of black band, where are we expecting G12 to sit? So low? No one? Middle? Okay. High? A couple of highs. So it's quite low. Interesting note, so between 2021 and 2022, we do have data going further back than this, sort of pre-pandemic. But one of the things we found, I don't know, we're all trying to blot out COVID, but hey, is that when the first lockdowns hit, a lot of people's incomes dropped, but actually their expenditure dropped, or average expenditure dropped much faster than average income. So things like overdraft fell away quite sharply in everything but like the lowest income groups, where it actually just tended to sit quite static. Hopefully for fairly obvious reasons, that if you're already on the breadline, then your expenditure doesn't really drop. So I think that's what we're seeing there between 2021 and 2022, is there were lockdowns during that period, and so expenditure dropped, and that reduced people's use of overdraft. And then as we saw opening up through 2022 and 2023, then we're starting to see that increase in overdraft again. It's relatively low, but I suppose possibly as the student population has arrived back and things like that, we're seeing some of those overdraft values creep up. And finally, income in the G12 postcode, low, middle, high. I was kind of surprised it was as high as it was, actually. But so, yeah, we can see, similar to the last plot, there's that drop in income through 2021 as lockdowns happened and people were working less and all those other things. So some of the use cases around this, how am I doing for time? 5 minutes, that's okay. So we've been working with East Renfrewshire Council, just to the south of Glasgow, and got a little screenshot of the dashboard that we've built with some of this data for them. We've brought in a lot of contextual data sort of around some of their policy drivers on child poverty and fuel, sort of home efficiency type things, so they can compare stuff like overdraft use or energy spend to things like how many properties have got poor energy efficiency, those kinds of questions. We think this kind of stuff would be really useful for interventions and baselines. So say you are a local authority and you're thinking of adding a new bus route, and you could say, well, what's the income in an area beforehand? I've added a bus route, what's the income afterwards? Has it enabled people to go to and get different jobs or more jobs than they would have done beforehand? Like what's the cost benefit on that sort of society piece in terms of the financial well-being of the groups in there? I think it's kind of like a canary in the coal mine. Like I say, I mean, I think we all have personal knowledge of where the areas in financial difficulty are near where we live. But what's, I think, really useful here is that we can start to see financial difficulty before it's necessarily manifest sort of visibly, that you can see people starting to go into their overdrafts or where their disposable income has fallen below certain amounts. And this can obviously help drive planning and policy changes and all of those in sort of local and national governments. So future development stuff, we are super keen to start doing this in England and Wales. We've got some other metrics we are beginning to work on around net zero homes. So those who are most vulnerable, like how do you do a just transition and target support in those areas which need the energy performance the most, but also can least afford to make the change. Things on public health and child poverty as well. And then very quickly, can I do 2 minutes on maps with R? Yeah. So why? I mean, like I work with R a lot. Actually, quite sadly, I don't actually have QGIS installed on my laptop or Grass, which is like, I don't know, the first time in years and years. But maybe it's just a sign that I make less maps than I used to. I love the scalability that I can write code once and then reuse it many, many times. When do I do it? I tend to do it when it's really quite straightforward. Plots. So instead of it being cartography, more just like a spatial visualization rather than I am making a map about an area. And is it easy? I mean, I think so, but I guess you'd be the judge. So the geocomputation website has got loads of great resources in R and Python, and often like in little toggle switches that you click on the switch, you see the code in R, click on the switch and it shows you the code in Python to generate the same output. I've used ggplot, which is an R package for the figures you've seen here. And if you can't see this at the back, because I can't, so I made it bigger. And in order to make that figure that I had just there of Scotland and each of the postcode districts, this is effectively what I did. So I loaded the tidyverse and the SF packages. I loaded the geo package because no one uses shape. And so I checked the ST layers to see what layers I'd put in this geo package some years ago. And it's got one on postcode district and one on postcode area. So I read that in and then I plotted that and I added the SF. Like that's everything that makes the plot here. That one. And then you can do colors and all those other fancy things, but that's effectively it. So as a quick summary, R's great for data visualization maps. Finance data can supplement statistics. For us and our data partners, privacy and trust are key, and we are super welcoming for collaborators and use cases. Thank you.
I think we do have some time for. Yeah, why not? Yeah, we have some time for questions if you.
You saying about this? What's this doing?
So I just turned on the microphone in the room so people can hear.
Ah, okay. Well, that's very fancy.
I was going to talk about, I just had a sort of a question about the time series stuff. Is there, is that also part of the visualization outputs as well, rather than bar graphs? And is there any plans to use potential predictive analysis to kind of project into the future?
So, I mean, it's super small for a number of reasons. But so this dashboard view is based on the dash from SuperZip example that's on the Shiny Gallery for POSIT, if you're interested in having a look. But as you, the two plots up there on the right, so the top one is a time series of everything that's visible. So as a local authority zooms around the map, it displays sort of the data in view as a time series over that period. So yes, that's kind of what it is. There's a second part as well.
That covers more about if there was any plans now or in the future in terms of using that data set with
predictive stuff. So kind of my view on this, and I think the same view with AI as well, is that this stuff is so new for sort of public sector or decision-making use, and so new for research that there's so many things we can do with it that don't involve really chunky guesswork, like AI or sort of whatever else. Now, that doesn't change the predictive piece. I think it would be interesting and useful, but I guess like the idea around this is like we are able to see from, I guess, like current account use, things that we wouldn't expect to see. So a pointy stick, probably. Maybe does this work? So over the sort of the yellowy, oh hang on, I've got a mouse, haven't I? If you go to bed earlier, that's the problem. So this area here is Barhead, and it's sort of had long-standing traditional poverty, and so no one is surprised that it scores quite highly for overdraft use and lots of those other things. Whereas over here is sort of the edge of Netherley, and it also scores quite high for overdraft use, and the local authority were really surprised about this. Now, there may be some data resolution issues, but quite possibly, one of the things we were asked to look at was about people moving into East Renfrewshire for school access. And did that mean they had over-mortgaged themselves and suddenly found themselves in, and particularly in homes with poor energy performance? So this area of high overdraft use also coincides with areas with really poor energy performance. So, you know, if you mortgage yourself up to the hilt in order to get your kid into a better school, and then you've discovered that, you know, that lovely fireplace, high ceilings and cornices actually just leaks heat. You know, it's, yeah, you've potentially found yourself in a really weird situation. And yes, I suppose we can diagnose that afterwards, but I suppose my worry about the predictive piece is we can only predict based on our own biases and assumptions, not necessarily based on something that we wouldn't have seen, say, 10 years ago.
So I have like two questions, mainly regarding the pipeline process.
Do one at a time, so I've got a really short memory.
I'll take one. So regarding getting your data, I know that you said you use sample data from NatWest Group. What's the process look like obtaining that data? Is there a portal that you go on and you put a request in, or?
It's extremely lengthy. And I think this is, so while like Rosie and I are in a data science team, I think the biggest value Smart Data Foundry has as an organization is the relationship building with the financial institutions. So even with existing data sharing agreements, it can take us a year to get new categories of data. The initial setup stuff to get the basic categories took maybe 18 months, 2 years. It's really, really long, driving that through all of the kind of decision points within the bank around like what they want to do for their corporate responsibility, what they want to do in terms of maintaining privacy, how we safeguard that and make sure all of those things are okay. And these are, I guess, like right at the moment we're in really tightly defined data sharing agreements. So we're allowed to use NatWest data for the cost of living crisis, which obviously makes total sense. But if, say, someone wanted to come to us with a gambling question, which sort of, there is a lot of interest in that, but we then need to go back and have sort of host those talks or mediate those talks with I suppose not just NatWest, we've got other banks and accounting firms and things as well that we work with. But yeah, it's really long. And we've got a very strong information governance team who help us with all of that.
And then the next question is bringing your insight to the market, to the council. How quickly do they get that data and go actionable with it? Do they take a year as well, or do they take a couple of, or do they work according to their own schedules?
So, for Easter and Fuchsia, we host a dashboard for them, and careful exactly what I say, as I'm not quite sure what the contract is at the moment. We get new data from NatWest-ish every week. I mean, like I say, sometimes they send it every fortnight, but we get weekly data generally once a week. Sometimes people are on holiday and maybe we get an update once a month, but we'll get 4 weeks of data for that month. So we're really reluctant to commit contractually to weekly updates for a local authority, because we can't guarantee we're going to get that from NatWest. But quarterly is absolutely achievable, but it could be more frequent than that. I'll let you.
Yeah,
pointing at people.
Maybe if it's a quick one, yeah.
I guess looking at moving statistics to like faster updates, which is the point of this, right? What's the previous kind of? It was like last year's tax returns from HMRC kind of data, like.
Yeah, so we call it Department of Work and Pensions. Basically, DWP would send data on benefits claimants in these small output, or actually probably small output areas that are aggregated up. So yes, that could be more frequent.
Like an annual thing, but maybe up to a year behind, or
yeah. Thank you. Yeah, thank you.
The next speaker will be Junaid Abdul-Jabbar from the University of Cambridge, and he will be talking on mapping archaeological heritage in South Asia, open source technologies, and sustainability.
Thank you. Good afternoon, all. My name is Junaid, and I am a geoinformatics engineer, currently working as the geospatial database developer for Mapping Archaeological Heritage in South Asia project. So in this session, I'm going to be talking about some of the open source technologies that we are using and the steps that we have taken to make the whole process more sustainable. So starting with the introduction to the project, Mapping Archaeological Heritage in South Asia project is mainly based at the University of Cambridge. It is funded by Arcadia, and it mainly focuses on the documentation of endangered archaeology and cultural heritage of Indus River Basin. So it makes most parts of Pakistan and some parts of Northwest India. So all the data that is being documented will be made available through an open access online database. While it's open access, but it will still have variable level of access depending on the user roles, because it's the heritage data is quite sensitive in terms of value and preservation. So this online database is being developed using Arches platform. I'm going to be talking about a lot more detail about Arches in the next few slides. So the aim of this database is to provide an open access mapping resource and research repository, which is a collaborative research output with the local heritage professionals. We have collaboration in both Pakistan and India with the academic and both at the government level. And the project has a built-in series of training programs for the capacity building of the stakeholders. Talking about the data sources that we are using to document all this archaeological heritage, one of the main data source is historical maps. So we are using Survey of India maps that were developed as part of Britain's colonial presence in the South Asia. So these maps have actually from early 1900s have proved to be a very rich source of archaeological sites. And The importance of these maps is that these predate most of the urban and agricultural expansion, because a lot of urban expansion and agricultural expansion has resulted in loss of archaeological sites. So these historical maps predate that, and hence they are proving to be a great source of that information. So the way we are doing is that we are getting the high resolution scans from the libraries and then doing a georeferencing on it. Over here, you can see a map that shows you mainly three colors. The green ones are the maps that have already been georeferenced. So it's a very good coverage of the study area. And then the yellow ones are that have been scanned, and the red ones are that are currently being georeferenced. So this is a live map that you can also find on the official website for the project. Another source that we are using is the legacy data. So all the publication and books that are in digital or non-digital format are getting documented in a structured format. Then the remote sensing, we are using Google Earth imagery, and along with some of the old Corona satellite imagery from 1970s. The project is also doing field surveys to ground truth the data that is available from other sources or collect new one. Adding to this is another data source, which is basically machine learning. It is based on the historic maps. So one way to deal with this was to georeference the historic maps and then manually go and look at all those archaeological sites and then digitize them. But in this process, we have a team, some partners who are working to automate this who have worked to automate this process using machine learning. So in the bottom, you can see that these archaeological sites or mound features have specific visualization on the map sheets. So the machine learning algorithm is trained on these representations, and then it runs on the bulk of map sheets to generate a spatial output. Over here, you can see the result of one of the runs. And as we add more maps to it, it's a matter of minutes that it will detect all those archaeological sites in a very quick way. So this data, because you can see there are a lot of sources from where the data is flowing in, it all gets collated into ArcGIS database platform. So ArcGIS is a very rich and feature-rich platform, but it's also it can get a bit complex to deal with. So it's an open source web-based geospatial information system that is specifically designed for cultural heritage inventory and management. It's developed by the Getty Conservation Institute and World Monuments Fund. On the right side, you can see the image for the search page of ArcGIS. So you have options for spatial or non-spatial search, deal with the map canvas, do advanced search using operators based on the data type or specific attributes, download the data if you have right, and more. So the standards that ArcGIS uses to have this data are based on SciDoc CRM ontologies. SciDoc basically provides you a conceptual reference framework to manage cultural heritage data. So in ArcGIS, you can define your data structure, where you can use the specific classes from SciDoc and assign it to your nodes or attributes. This is all done using a special graph structure that is referred to as resource models. A resource model can be seen in this image over here, that it is a list that comprises of nodes and branches. Nodes can be thought of individual attributes, and then branches can be thought of as a group of attributes. For example, a name is a node, and if you think of the whole name branch, name and name type, together they become a branch. And it can be visualized in a graph structure over here in this way. A benefit of this graph structure is that you can configure some of the branches to allow multiple instances. For example, if you configure the name branch to be multiple, then one site can have more than one names. which can be categorized into primary names or alternate names, depending on the data set. And it offers a number of data types, like to assign to your nodes or attributes, which include numbers, strings, extended data type formats, or one of the very interesting ones is the concept that is basically control vocabularies. So any attribute that you don't want to have just simple text, or you want to control it with specific terms for the eventual benefit of clean search or standardized data development, you can assign the concept data type to that particular attribute. It can be translated to control vocabularies. For example, like in the ground geometry recording method, you only allow the users to enter values like ground truthing, legacy data, or remote sensing, nothing open, so that the search is clean and all those functionalities. And a powerful thing about this concept data type is that it can also be hierarchical. Like there is a parent and then it has some children. For example, in the top right, you can see that ground truthing is a concept and the geometry recording method, but it has further children's, which include handheld GPS, phone, tablet, built-in GPS, or total station. And the system is intelligent enough. If you will search it for total station, it will give you very specific result. But if you just filter the record for ground truthing, it would also pull in all the child records, which have values for handheld GPS or others, so that you can give a full picture. Arches also allows you to relate different resources with one another in the database, and you can actually read across the resources. For example, in the middle, the red one is a historic map, which is associated with 3 resources. And if you look at the side panel and the report page, then you can actually say that this Punjab map has been georeferenced. The activity is carried out by Jack Tomini. The right is held by Cambridge University Library, and the survey activity was done by Mr. E.O. Wheeler. So as you can see, it's a quite rich platform, but we have come across a number of challenges that I'm going to explain in next few slides. So there is a capability, like, because resource models are totally customizable depending on your requirement, Arches does allow you to go into a number of nesting levels. And as you increase the number of nesting levels, the data structure gets more and more complicated, and it becomes a bit more complicated to push data into Arches. For example, but there are genuine use cases that require you to have that sort of complex structure. For example, one heritage site can have multiple condition assessments associated with it, done at different points in time. And then each condition assessment can have more than one disturbances or risks or threats associated with it. So if you start going into deeper level of nesting, the data import becomes quite difficult. And this was one of the major challenges that we were faced with when we started the project back in October, like towards end of 2020. And at that time, there was really no provision to import this data without getting a very complex JSON object, which had its own specific format and all that. So to deal with this multiple attributes, Arches recommends the specific type of data format. If you see in the tabular or the CSV format, you have to use a multiple row structure. For example, you would make the common resource IDs to tell Arches that it's the data for the same resource, but then you will use multiple rows to specify the other. In the example at the bottom, you can see that site number 2 has more than one name, Mohammadi Derai primary name and Khazana Derai alternate name. So you just simply made two rows for it. But what if you had a site that had 2 condition assessment, and each condition assessment could have more than one disturbance? In fact, you can imagine that the file would start getting very complex. You would have to go into the sheets and all that. So this was a major challenge to us, and we had been talking to the larger Arches community and the team that is developing most of the features, Arches, that's Farallon Geographics. And since then, there have been a number of releases for the software. Sorry, I'll just talk a bit more about the data structure. We had to use this data structure anyway because it has its own advantages. For example, in the study area that we are working with, there are challenges like provision of internet or working in an offline environment. So we did make a formatted CSV file structure on top of the recommendation that ArcGIS gives. So it's a very colorful Excel sheet that you can work with. It has indicates that whether the attribute is allowed for multiples or not. Then it indicates the data type, which is the concept or string. Then the name of the attribute. You have drop down for control vocabularies to avoid any mistakes. Then colored columns too for easy identification of the group of attributes like site name or the assessment activities. And then unique MASA IDs that you have seen in the previous example. You need that MASA unique ID so that ArcGIS knows these all attributes are associated with the one site. But still, where we could not totally get rid of this format, we needed to have something more sophisticated to bring it into ArcGIS. And that's what we had been talking about with different other Arcadia funded projects and the company responsible for development of ArcGIS. And since late 2020, there have been a number of releases which can be seen over here. Now it's been very interesting to keep on updating the instance, but you can see that it's been over 18 new releases since then. And one of two major releases that are particularly interesting were the version 6, basically, that released a new method to import data into ArcGIS using the relational or schema or SQL ETL methods, which would deal with the complexity of this nested uh, data structure. And in version 7, there was a release that had internationalization capability, so you can translate the whole platform, both static labels and the dynamic data, into local languages. For example, two of the main languages that we are working with are Urdu and Hindi. We started to study this SQL ETL methods or relational schema to get more understanding how we can get data into ArcGIS. And relational schema basically converts your whole graph data structure into a standard Postgres relational database. You have SQL function over here that's ArcGIS created source model views, and you give it the unique universal ID of the graph, and it will convert it into views. So you can see that our main resource model, that's heritage location, it got converted into 44 views over here. So when we got the understanding of this new venues were open, so we thought, why not to improve the whole data digitization process, which is solely based on the CSV files. Maybe because this is all geospatial data, maybe we can define the whole pipeline. So when we got more familiar with this and got more control over the back end, so we started looking into that setup. And as a part of that, we made a centralized instance of Postgres and some QGIS forms. So setting up the centralized database was that we made sort of a copy of the ArcGIS backend, but a bit light. It's a whole relational database with all the attributes field from the respective resource models. In the ArcGIS relational views, they use a JSON binary structure because they have to cater for the multiple languages that were made available as part of ArcGIS version 7. So in one object, you can save the text for Urdu, English, and Hindi. But for our own case, we kept it light and we use simple data types like string to ensure effective communication, secure communication. We configured the SSL for Postgres, and then there is an automated backup routine using cron jobs as well. As a front end for this, we decided to make a QGIS form. And to do that, we had to do a number of settings in the QGIS project. So first, we loaded all the relational tables from the database. Then QGIS allows you to discover the relationship based on the primary keys and foreign keys. This is a very nice functionality that Postgres offers you as compared to geo package. Like if you have relations in the geo package, you have to add them one by one. That becomes a bit cumbersome if you have a big relational geo package. So this was very good. And then you load all the relationships. Then you have to configure the edit settings so that the editing can start on all the related layers at the same time, because you have to enter the data for multiple layers and then save it also in a systematic way so that it does not violate the primary key and foreign key constraints. Then we designed a data entry form for it using the standard QGIS widgets, added some user constraints and validations to help the users. And then we set the layer visibility so that only a subset of layers is available to user, because otherwise it's more than 30 tables that can be confusing for the person who is not familiar with the backend. So the QGIS form looks something like this. On the left-hand side, you can see the person responsible for entering the data, the associated MASA ID. Then on the top, you can see all the cards available, like assessment activity, site name. These are all the branches of the resource model, basically. And because it's a relational database, so you get an edit button for the site itself, and you can add more than one site names as a group. So I would like to call out John, who worked on this form, and he might be watching online, so that would be good. So yeah, now our whole team is working using this QGIS form to enter the data. When this data is available in the centralized instance of Postgres, I knew the concept of foreign wrappers. So foreign wrappers allow you to access one database into another without the need to create a backup and restoring it into another Postgres instance and then running the queries. So in a live connection, you can create the foreign wrapper for centralized DB into Arch's backend. And then you have to write a lot of SQL queries with a lot of functions. But once it's done, it's done. So you can have a live sort of a sync between your CDB and Arch's. So here is an example of some of the SQL queries that you can see to push the data. And once that data is pushed into Arch's backend, you can just index it to the search using some standardized command, and it gets available into the interface. So this is the one of the resource model that has been imported into this using this whole pipeline. So it has streamlined all of the process that we now have a complex data structure as well. The team can work on a QGIS environment because it's spatial data, and then the management and all ingestion has been streamlined. We also have a component for field data collection, as I talked earlier. So Arches initially came out with Arches collector, but because it's the whole open source software and the community contributions and all that, so as I mentioned that there have been 18 releases already, so it's a with variable pace of development for the main software and then the Arches collector. So with the recent versions, it's not working very seamlessly, and there is a proposal on updating the technology stack and making a new version of Arches collector. But meanwhile, we had to adopt another open source technology, which is basically ODK. You might have worked with it. So Open Data Kit is an open source mobile data collection platform. It has been very useful for our requirements because we have to work in remote areas where sometimes good internet connectivity is not present. So you have to collect data offline, which is allowed by ODK. One of the very interesting or useful capability that I can say is the preloading of existing data. Because Arches collector is not there, if it was, then we could have just connected it to the main instance of Arches and then our ground truthing. But now we have to preload some of the data into ODK. And when we started working with it, there was no interactive way to do that. And this widget was rolled, I think, somewhere last year around that time. So we use this. This needs to be uploaded as CSV file to the server. And from there, you can configure your XLS form to load the data. When you click on it, it will pull up the attributes from the file, and you can see what's the data and collect new data. And it has also allowed a lot of user scalability because the way the project is set up, we have to do a lot of trainings for local stakeholders in both Pakistan and India. So sometimes when it's a university, they bring in a lot of students, and because it's a free solution, so we have the provision to scale it up, give accounts to all the students. They can do test run into the field. So it's very scalable in that way. And again, it offers multilingual forms, so you can translate the form into Urdu or Hindi. So we have tried to make the form useful where possible, with hints and colors, because it has some repeat groups embedded in it. So the users, to make it easy for users, we have introduced these images, and control vocabularies are same as the main Arches instance. For example, you can see overall site condition assessment. So it has some same control vocabulary that the user can select from. And yeah, this is being used for a number of field seasons already. These are some of the images from field, where our team is working with the local people while collecting the data or doing the capacity building. So yeah, really it brings it down to this one slide, like how the data life cycle looks like. It starts with the data sources, historical maps, legacy data, and all that I've talked about. Then the data development is based on different tools like QGIS, ODK, structured CSV files. We are working collaboratively on SharePoint. There are different quality assurance checkpoints because it's so much data inflowing. Different research analysts work with different collaborators to ensure the quality of the data. It all gets together in centralized Postgres instance where they are doing day-to-day working. And then from there, it's pulled into Arches using an automated pipeline that I've just talked about. So we have been like the sustainability of all this process has already been improving. We have a new sustainability group that is basically a collaborative group. We have meetings with multiple Arcadia projects where you can discuss how to keep these things running in the long term. Arches is also a sustainability consultant on board. And there has been much more community engagement using the Arches project community forum. So it's very active. You can get very quick support. And also if you come up with a new solution or you know the problems to errors, you can comment over there. Finally, I would like to thank all the partners, collaborators, and our funder for all the support that they have given. And that's it from my side. So you can visit our website for more information. Thank you.
We have time for some questions. Yeah, in the back.
Thank you. That's a really nice project. And the Arches site says some of the developments supported by Natural England. Is there any use of it that you know here in Scotland? Is Historic Environment Scotland ever been asked about it?
If I understood, you're asking about Arches usage in Scotland. So yeah, there are quite a lot of projects. I mean, I know about Arcadia funded projects that are spread across the globe, like some are working in Africa, some in South Asia. Then Historic England is also using Arches. I'm not 100% sure about the Scotland uses, but on the website there is a list of all the projects that are, and in the recent page they have said that it's more than 100 projects that are actually using Arches.
Any other questions? All right. Thanks, Sinead. And it's time to introduce our final speaker for this session. Paul Georgi is a geospatial technologist at GeoGeo, and he will talk on Unreal Geospatial, Rise of the Game Engine.
Oh, turn that down. Spoiling it.
Sorry.
Thanks very much, guys. Yes, my name is Paul. I graduated from Edinburgh University's GIS course in 2010. Before that, I've been doing work within the predominantly international development and humanitarian response sector. And as Helen maybe touched upon at the start of the day, most of my job, I really feel, is just advocating for people to think spatially and understand the concepts of one geography and acting that way. So within international development, there's the usual 3 schools of playing with natural resource development, public health, which is where I sort of began, and rural development. As we moved back to the sort of more industrialized nations, smart cities became sort of 4th topic in that, which I'll touch upon later. And most of my mission that I've been doing is around building resilience and helping a transition towards a low carbon economy, which is why for the keen-eyed people amongst us, they would see that my logo is actually the Cahill projection or the Waterman butterfly projection. And the butterfly is actually a symbol of resilience, and green apparently is the color of resilience. So a lot of the things that I've done over the last 12 years with GeoGeo has been mostly trying to promote within government, communities, and other international NGOs the sort of best practices within GIS, and to help build predominantly open source solutions for usually web and mobile applications. But from day one, particularly when I started joining the fixed wing drone game in 2013, has been really to be breaking game engines to see if they were ever capable of taking the kind of geospatial data sets that they produce. And actually, it was only really when Unreal Engine upgraded last December that we started to see this new opportunity. So this talk today is about the rise of the game engines. And I guess to start with, we're all quite geeky here, I assume, but you know, if we want to show of hands, who here would identify as a gamer? Just a wee raise of hands. Board games count? Warhammer and Games Workshop, painting figures, that counts. That counts. I would. And I'm going to try and make the argument that game engines are not too dissimilar from the world that we love and know in GIS. Oh, that's not going to do it. Oh, okay. So what are game engines? There'll be some interactive testing throughout this, especially for those identified as gamers. And for those of you who don't, this is the greatest football game ever made, Sensible Soccer, made right here in Scotland, specifically in Dundee. But you can break down game engines to me into 3 simple pillars. One, you've got the physics side of it, the actual ability for you to hard code the way that actors and agents will interact with their environment. It's not too dissimilar from what we did in Edinburgh with agent-based modeling and tearing our hair out with learning Java and object-oriented programming. The other thing that it brings is similar to simulation, which is to be able to animate these features and actors and assets, as well as create other amazing animations that belong into other games, like to give an immersive kind of atmosphere. And the third pillar, which if you're a geospatial kid that falls down a rabbit hole into game engines, you will absolutely become addicted to, is the one thing the GIS can't do, which is sing back to you. And the audio processing within game engines, when coupled with GIS data, creates this love for location-based sound that, you know, if you do want to begin this world, I would recommend that. You'll probably learn a lot about that. This talk's not going to be very technical. There's going to be any code. If you want to learn more about the things that I'm talking about, there's the University of YouTube, or as Amy also acknowledged, the Stack Overflow, which are great places. Discord is also really good, especially because most of the plugins that come with these game engines have their own Discord channel. So there's a thriving online community. And because we're in Glasgow, it's easy for me to break it down. In the world of game engines, unless your name's Rockstar North and you've decided to build your own engine in-house, there's the Celtic and Rangers. And I'll try not to show my side of that story, but Unreal Engine will give you free access to all of their game engines completely for free until you make that first $1 million, and then they'll take a little slice. Unity, you almost have to pay at the gates to get in, but you also, by doing so, welcome yourself to a whole list of other functions and plugins and assets. So there really are 2. I went with Unreal Engine because for me, it's the closest to the open source side of things, more so than Unity, for having to pay at the door. And when you look at the applications that we're using, I'm not trying to make $1 million game, really. But yeah, so
we'll move on to the evolution and why this opportunity is starting to appear. Anyone shout out the name of this character? Zelda? No, close, but it's Zelda. The far one on the left was actually the 1982 flip game of Zelda, the first game ever with a continue button, as we move all the way through the years to the modern stuff in all 3D assets. But the power of computer processing has really exploded, particularly in the last few years, with too many crypto bros in the world using graphics cards and hogging them all up to do some mining. But now we're sitting at a place where these are really low cost for anyone to start adopting and having the ability to run these game engines. The other aspect that really drove that was just that human endeavor for us to experience things in a more real and realer, is that a word, manner than we have before. And our thriving desire for realism has been also at the core of how the community has grown as well. And of course, the data or geodata availability. I say data as well because it's unbelievable the amount of people around the world that are bringing free assets into this world. I'm going to show an example of Scotland, but I had no idea there were some hobbyists sitting on the Isle of Skye doing like high-res 4K imagery of just simple rocks, you know. And when you're working in the same biogeography, this has become an amazing opportunity to leverage the efforts that are happening on a global scale. Never mind the other aspects of making human characters, animals, unicorns to chickens. It's been an explosion in the last few years with that opportunity that's come from graphics cards being democratized. So the best part about this is really the introduction of geography and the idea that digital geography can now start entering the game world. I'm going to start with this slide because I'm kind of sick of seeing New York in a game engine. We get it. Their OpenStreetMap is the best. They've got some great 3D data sets, and they've got some great photogrammetry that's available for free. And everyone that starts on, especially on the University of YouTube, will be using the New York data set as their sort of gateway into this world. But there's also been a huge amount of benefits from bringing in the geospatial world in terms of using games to create something that is recognizable to you as a world. It's one thing to make an immersive experience that feels real, but it's still about zombies in a made-up land that's been drawn by an amazing artist. But here we're dealing with real-world geographies that brings in an entirely different human experience of how we immerse ourselves into that world and interact with it. And as I like to argue, then contribute to our understanding of it. And with that is also opened the door for real world applications. So I'm going to touch upon a few of those and a few of my favorites within that space. And we're going to play a game called Guess Where That Place Is. Okay, so we'll start nice and easy. Where are we? Spoiler alert, all of these slides are not real world pictures. They're all game engine photos. Please. Yeah. It's the Old Man of Store in the Isle of Skye. One of the first people first teams I ever heard speak about the role of geospatial within a game engine is the creators of Assassin's Creed, Ubisoft. And they've been going around both hiring, curating, and actually in some cases doing the work themselves of scanning the physical and human world. And credit where credit's due, if they had not scanned St. Paul's Cathedral before it burnt down for an Assassin's Creed game, then the architects would not know how to rebuild it again now that it did burn down. So they're actually really valuable things. But even though they didn't know they were doing it, this was from a game called Valhalla, which talks about Dalriada and the end of the Viking era. And it has real world locations of Stavanger, which is where I was raised when I was a kid, and the Isle of Skye. And so you're actually walking through this world, getting to learn and discover the way in which the Celts and the Vikings were interacting. And for me, without even doing it, they just created a generation of people that now know more about the Vikings than I learned in this very archaeological department doing archaeology of Vikings. So that ability for us to use game engines as a form of storytelling to help describe real world places and real world phenomenon is really good. I should say as a caveat this, before geographic data really got involved, UN themselves actually published a list of games which they felt helped users, predominantly Western users, experience things that they would otherwise not experience. there was a game called this War of Ours, which was a survival game that put you in the shoes of 3 random people that were in a war at a time inside a house, and your job was to make choices to try and survive or like salvage what you can, with psychological repercussions for all of those actions. And there were many games that were put in that. The very first immersive VR thing was a team led by a woman in New York. It was immersivevr.com, and the first 2 launches they had was, one was just the sound of bombing in Gaza Strip, but it put you in the market before you were there. And another one, which became a I Am a Man project, which was you are walking through 1950s America being treated as an African American as you walk down the street. And it was a very emotional and kind of like immersive experience that really put people into a world that they otherwise might not have experienced in the first place. So my first real interest in game engines came from this, just from my own experiences playing games and the other things that we were hearing from more international development organizations and things. Digital twins, AKA the latest catchphrase for smart cities, which I don't know how smarter it can get. In the UK, I mean, the good thing about doing international development is that you get to experience a vast array of countries. I've now worked and helped over 60 different countries, predominantly in Latin America, Sub-Saharan Africa, and Asia. But it's not like I ignore the UK and Scotland. In fact, that's why I moved back to Glasgow in 2013, was to, as the co-author of the Future City Glasgow Future City Demonstrator Project, where our job was to help spend £24 million in 12 months inside the council to see if we can create a smart city. Does anyone want to take a guess which city this is? Right side of the world, it's Singapore. And the reason I'm using the example of Singapore and not a single city in the UK is because Singapore took a much braver and proactive stance in removing the silos that we so enjoy in the UK between our public-private sectors. And that helped not only create a beautiful 3D world of Singapore, but actually add in all the data that was necessary to make the effective development planning application work. Best example is energy utility, transport, all of these things. Like if you forced Scottish Power and SSE with all their smart meters on everyone's apartments to share all of that data so that you have one building that has one reading, now you're starting to touch upon where Singapore is already at. Whereas, and now of course we were discussing about broadband. I live in the West End of Glasgow and I'm being attacked by the Sky from BT and underneath by City Fibre. And I was laughing at them saying, I'm so glad the Romans built the roads. And I wish they'd just been around to build the broadband, because then we just have one company to do it and there would be no fights, or never mind cables going everywhere. But obviously this is a really important application because of the main things around physics and simulation abilities as well. The idea that there are now simple plugins to add Internet of Things sensors as well. So you have the trifecta of imagery from the sky, data if you can remove the silos, and then the sensors being brought all together into a game engine that can allow that to be visualized and published onto a wide variety of things, everything from augmented reality to just interactive game worlds. So in terms of the most serious application that you will see being developed from a geospatial sector, I really feel that digital twins is definitely that. But as I'm just a sort of small consultancy that works in development, I don't really get to play with a lot of the big engineering teams that have huge departments doing this at the moment. But it is one of my favorite sort of things to keep an eye on. And I don't like to use the word Esri at a FOSS4G conference, but I usually avoid their solutions because they still stick with the silos, but they are also developing a lot of SDKs, predominantly with digital twins and development in mind. Does anyone know which island this is? It was made famous, this story, last year, because they've become the first island to have an entire island placed into a game engine and then hosted onto a cloud. This is the island of Tuvalu, which will be the first island to disappear. And yes, they've been given land in America for their future generations, their own kids and grandkids to live. But the sad reality is they've had to create a digital twin in a virtual space so that their grandkids will be able to visit that space on the digital world to share and learn about their heritage and culture. Because in the world that we live in, it's a reality for a majority section of the world that there's huge impacts coming their way. And I think this is probably one of the most tragic examples I've heard of the use of a game engine. But it also showcases what is a low-hanging fruit. I mentioned Unreal Engine and my love for that. They're run by Epic Games. Epic Games, if anyone with kids, own Fortnite. Fortnite is a virtual world that's quite big, made by an artist, not by a geographer. But it allows up to 100, 150 people to hang out. That hanging out is free. You build a world, you have a free method for having that in a virtual space, thanks to the donation of that code from Epic Games themselves. And that's exactly what is going to happen here as well. So it is about conserving our heritage, conserving our culture. And my example is actually based on archaeology, which is another fine example of how we can combine both the educational aspects and the conservation aspects as well, particularly if you have a coastline, or in Scotland's case, lots of rabbits, which kind of destroys archaeology as well. So that helps me move swiftly on to my project. So back in 2018, in a pub in Glasgow in the south side, my friend studied archaeology for the National Trust, who decided he wanted to hire a helicopter for an extortionate price for a pretty coarse data set. And I did not really think I would be flying fixed-wing drones in the Hebrides of Scotland. But when I told him the level of resolution that we can capture with, I fly the SenseFly EB, I have done for 10 years. It's autonomous, it's fixed wing, and the Aviation Authority said I could fly over cities and highways as soon as I started without asking anyone's permission. But we took it here in 2018 for 5 glorious days in November, a rare one as we're experiencing today, to digitize the entire island data set. With that imagery, we were enabling the archaeologists and ourselves to use predominantly QGIS to go ahead and digitize archaeology 5,000 years worth of human history in the making. There were some parts of the island itself that are inaccessible. So the National Trust Rangers had never been to some parts of this island. There's amazing history here. We're talking about the UK's first monastery and nunnery. The King of Norway is buried there. And it once was a thriving population of 500, now whittled down to just 15. But we were able to capture and digitize over 2,000 features of this island that was amazing for them. But archaeologists being archaeologists, as soon as lockdown happened, I had to ask the question, what have you done with the data? The correct answer was print it and still have it on one person's laptop that has QGIS. And so really it was lockdown that kind of helped spawn this desire for the National Trust to look at virtual tourism, which we started very simply. I can build a 3D mesh from the original point cloud, upload it to Sketchfab. We can add some narration, which was a Margaret Fay Shaw interview from 1945, talking about the island, as well as places of interest that we can animate around. It's very simple. It can be done in VR, it can be done in augmented reality. But the dream was, can you just give all the GIS data back and put it into a game engine with the amazing terrain data that we captured, and then create the world as it was 1,000 years ago? And of course, we could use it to make a digital twin for development planning purposes, but if they want that, they're going to have to hire me twice, where you get one choice, not two. And so we set about doing this. We are now using 5.2, but the demo that I'm going to show you today is from 5.1. Also, what happened this year is that a few of the plugins became free. So the one I'm using is called Landscaping, and there was another one out there called Terraform. And these are dedicated plugins that have been converting Python to C++ to help us import not geo packages, shapefiles, sorry, and raster terrain data sets. But it's still at the point where we are pushing it right to its limit, because you have platforms like Cesium or Cesium Ion, which uses coarse radar SRTM-based terrain data sets for the whole world. And you can take that whole globe and plug it straight in to Unity or Unreal, and you've got the whole world to play with. But anyone that's been wandering around Scotland knows that if you want to justify the terrain, you don't use satellite terrain. You want a drone-based or manned aircraft-based terrain at 5 centimeters really to capture it. And we ultimately had to make it coarser and coarser, and we got to about 50 centimeters. And yeah, we had to make a compromise because this is 21 square kilometers that we're talking about mapped with the drone. I think my record with PCs is the SRUC's future farming system, and that was 25 square kilometers. After that, you need the EPCC to really start doing this kind of stuff. And even then, you'll be breaking Unreal Engine. So we ended up starting things the GIS way. So like every other game world in GIS world, you start with the terrain and the raster data and you move on up. Land use, I used some OpenStreetMap data, but game engines will expose data sets derived from satellite imagery, because you notice when you're walking through a world when a river is just not lying perfectly to the actual hydrology. We then digitized around 300 lazy beds or run rigs. We got about 250 sheelings, which are the kind of squares there, because we started with polygons with the sheelings, and then we made that. I used central geoids to make it points and then categorize the sheelings into various scales of sizes, because sheelings are just round huts. We had then black houses, rectangular structures, but we kept them as polygons before putting it into Unreal Engine, because we wanted the orientation would really mattered in front of that, and also helped with the size of it. And then you had things like OpenStreetMap land use, so beaches, woodland, and I actually used the terrain data for itself to make a coastline there, which is vital when you remember that my favorite thing is location-based sound. So in the Hebrides, it's not very quiet. So I might turn this down so it's not loud. Here's a wee teaser of where we're at. The new version, I can show you actually after that, yeah. So here. In 5.3, now you can actually see as we've added all the lazy beds in here. We can even orientate the run rigs in a random direction. And you can see some of the huts. And some of the biggest challenges is just getting the terrain into the world in a way that it means that it doesn't drop off in the distance. You know, you want to be able to have Unreal Engine and your computing power be able to see the entire world 11 kilometers away. And that's where you have to make that negotiation with resolution and the actual world partitioning of the landscape. So we start with the original point cloud, or not the densified one, but obviously the 4,000 images that was captured with the TensorFlow EV, creating with the point cloud. This is what we started with before moving to QGIS and then onto Unreal Engine. So it turns out that Northwest European geography is quite well documented. So you can find yourself meadow data sets. You can interchange it with others. It's a bit dramatic with the music, but it kind of helped with, when you're listening on headphones, the deafening sound of ocean and rivers. But you can see that we used AI in Pix4D. I could have used OpenDroneMap possibly to do some land use classification. So we actually created the terrain model, the DTM, to put that into the world, so that we can then put the trees back on top, the buildings back on top. And then, amazingly enough, like GIS, slope analysis. So where the terrain goes over a certain slope, we tell Unreal Engine, well, paint it like a cliff. And that's one of the sort of many ways in which you can start using Unreal to automate land use. And you'll see the river data sets there with the proximity sound of streams. And then you'll also see the OpenStreetMap wetland areas as well. So we're able to use that to tell Unreal Engine to actually feed in wetland areas. And this version doesn't yet have the sheelings and black houses quite in it, but I'm not actually allowed to show you that till next month anyway. And there's an example of the wetlands. But even when we started presenting this to the archaeologists at National Trust, we were quickly able to differentiate their interpretation of moving through this game world compared to traditional GIS and printed formats. Like when you walk through a settlement, you actually start to see, right, well, maybe this would have been something that's more pottery production, or maybe this one on the coast is something that would have likely been more fishing. So the next level is for us to then take a series of artifacts that relate to the actual human living experience, to go beyond GIS in terms of what we can create as a game world to now create an immersive experience for archaeology, to populate these things, to enrich the community that we can allow people to use. And actually the first use that will happen is not that we release this as a game for people to play, but for a game that archaeologists themselves will give you a virtual tour of. So they will walk through, and anyone that's made friends with archaeologists know that they're quite eccentric bunches and like to talk very passionately about the worlds in which they're sort of excavating. And to give them a tool to explore the world will really be a good example of the benefit I was touching upon in terms of storytelling, while also keeping it true to life accuracy of the real world geography that existed 1,000 years ago. And so with that, I always leave with my favorite part of geography, which is the first law, which I always paraphrase as you always know and care most about the things closest to you, which is why I feel like working together with these types of government and community organizations and teaching them about GIS is the most rewarding, because you really get to then translate local knowledge, local storytelling into geographic data sets, and now a digital geographic open game world. With that, thank you for listening.
Short questions before we break off to lunch. Maybe.
That would be interesting. Game engine, what does it use to populate the vegetation on the terrain? Is that like rules set up with regards to on this slope? You said a bit about that. You know, on this slope, this tree won't grow, or this elevation, or is it overridden by then data you put into, or is it a combination of both?
When you first import the terrain, it creates a landscape actor. And our first issues that I produced too many landscape actors and some of them would drop off. So we got it to this one landscape actor that's been produced. And then with that, you can create a default paint layer, which in this case, I named grass. And then within blueprints, unless like Stephen next door here, and I'm a wizard in C++ as well, you can hard code it. But then there's Quixel Bridge, there's all these 3D assets that are available to download. And actually some of them even come with the rigging, the skeletal structure to blow in the wind. You're really just creating a blueprint that says grass layer equals this type of grass. And then from that, I add other layers like with polygons to say, right, well, here's the wetland one. Wetland equals this. So a lot of it is just tiled in a very sort of neat way as well. But one of the things I was looking at, because I was starting with the drone data itself, when I did the land use classification, you can kind of infer things like high vegetation, like the classic land use classification categories. And so when I was looking at coastal areas, for example, rocks, AI often thinks is either building or like rock surface. But when I add that and export it from QGIS as an image file, I can upload that with the same GIS plugins to Unreal and then give that a different personality and say rocks itself. You know, so with the terrain, it's really just got one paint layer, the grass, which you can kind of chop and change. You know, you can move it from depending on the asset that you have, and then the other paint layer for the terrain models created just by slope analysis, and then do that.
I get one more question.
Something that's always fascinated me in open world games, like I wonder if you know anything about Red Dead, where they're taking real world, putting it into a computer game. It's how they deal with scale. So you're taking something that's real, and it's in your video, the person that run really, really fast to get past.
I mean, yeah, I only had to, the characters are all slower now because it's a 21 square kilometer world. It would just take you too long for the National Trust to test it if they were walking at a normal pace. And that's maybe the difference. But with games like Valhalla, they've kind of done a bit of a blend. Like Old Man of Storm is a real sky. The whole island sky has been shrunk. It was the same with Stavanger. They had certain islands that were like done perfectly, but ultimately the world itself had shrunk. And when they shrink the world, it's because they're using very coarse landscapes like cesium ion that streams at free as SRTM data set. And that's much lower processing demand than if you
are as silly as I am and just try to map an entire Aberdeen island set and put that whole data set in. So I wouldn't be able to do this for like Glasgow with a drone. If I was to do other locations, you would go satellite based because you know it would be easier on the system. And that's where games like open worlds like that are really easy. And of course, the other thing is that most of other games, huge open worlds, are done by artists. So it's a lot cleaner than a 3D point cloud from the start. Clean architectural edges, that creates a lot less triangles and a lot less problems.
All right, thank you. I think we have to break up for lunch because we have to be back sharp at 4:32. So the lunch is in the hallway, and you can use this room for eating or the other room as well. No.